this is the graph of x to the power of 4. As you can see, it looks like a quadratic that's got some winter weight on it. It's very, very similar in its shape. And so what we've got here, if I was to go to page 3, if you want to go to page 3 here, you'll see we are expected to be able to draw the shapes of quadratics. So what we're going to do, you'll see here where it says y equals ax to the power of 4. Well, the joy about drawing a big old quartic, he said, stumbling so he can get his ruler, is that any quartic that looks like in that form tend to look something like this. So you can see here, so there's my axes, and the graph, bleh, I'm a quartic, bleh, sweet Jesus, bleh. Okay, so there's your quartic. It just basically looks like a slightly wider quadratic. Thank you. Alright, so you'll see here that we get this lovely shape if a is greater than 0, so a positive number. So this is an example. Oh, we need to label this graph. This is y is negative x to the power of 4. So as soon as we get a negative, it becomes an upside down. So whenever there's a negative sign in front of the graph, it's a frowny face, or it's upside down. So it's the same shape, approximately, as the ax to the power of 4, just upside down. Thank you. Alright, thank you very much. So zone 3's graph you'll see here is in the form of x to the power of 4 plus 3x squared. That's what I had given. And you'll see it has the same shape as the other one here. So the only thing about this, the difference is that it's usually slightly stretched up. So it is the same looking shape. So if you've got something in this form of ax to the power of 4 plus cx,
would you be able to?
I can move that down.
Was that number 3 or number?
This is number 2. This was graph number 3, but shape number 2. And the only difference usually is that it's a wee bit wider, a wee bit narrower, I should say. So you can see here with this one. So, yep. So the last one, there's just one more thing that needs to be done with this. I'm just going to fix it up here. I'll make sure I get the right color. So I'd hate for to. There we go. So with this particular version, which was the x squared, and then we had 2 brackets here, you'll notice here that we're getting a bit of sag down the bottom here. So we're not getting quite the wide parabola looking curve, but we're getting 2 bumps here. So the shape of this kind of graph will look something along the lines of okay, so this was graph number 5, listing up things. So you'll notice there's no x at the front. Both the brackets are squared. So this operates in the same ways that cubic does. You might remember the cubic that's in the form of the bracket squared. Basically what it does, it comes down to one x-intercept, which is at -2, and then turns around and it'll hit the other one and it'll move straight on there. Okay, so this one's slightly perkier than the other one. It's not sagging underneath the x-axis, it's staying up there. Okay?
So it sits on the line.
It sits on the line, sits on the axis. So, for this one here, would you be able to pass that back to Miss Shegold, please? Just only the ones in your head.
Yes. That's the sound of music.
So the difference here is that this goes under the x-axis and this one goes above the axis. We've got This particular quartic is now going to look even more melty than the other ones. That's a technical term.
Yeah. Yes. As they all are. Yeah. You'll get marks for melting graph.
Yeah. So you can see here.
So it sort of flattens out a bit on the second.
Yeah, because that's the cubic part. That's the cubic part there, being all melty there. And then that's the other point here. So that will be the, in this case, it will probably be B. That will be C. Okay. So the final graph, listening up, thanks. Which has just got all of the x-intercepts labeled out there. Listening, please. You'll notice there, it's exactly the same sort of shape as these two, the middle ones. The only thing that's different is that when there's 4 x-intercepts, it just makes them huge. So you'll notice here that's like one of the values, like negative 3.5 is already at like 51 and so on. So these just make these graphs incredibly huge. So thank you very much, Ms. Bond. So the shape of this graph looks like the ones in the middle. Sorry? Yeah, there should be 4 x-intercepts.
Yeah, but click the last one up. Yeah, sorry.
Sorry, should look so. Okay. What we're going to do now is the other thing you're expected to be able to do, which is to be able to sketch a quartic from nonsense like this. So you'll notice here, in all of our graphs, we've had everything has been put in lovely brackets, so you know where things are. When you've got something, a monster like this, we're going to have to factorize it first, then sketch it. So, to do this by hand, so the first thing what we would do is we would use factor theorem. So factor theorem is basically I'm going to substitute a bunch of numbers that fit inside 36 in order to be able to find out if there is a factor. So I'm going to, well, 6 might, 1 might, 2 might, 3 might, 4, 9. I'm going to start with the smallest numbers. 1 was probably the one I'm going to start with first. Okay, so that's not going to equal 0 anytime soon, so those will cancel out, but 6 plus 11 minus 37 is not going to be 0, so we'll try -1. Nah. I'm going to go with Mr. Musgrove's suggestion of 2.
Yeah, 2 work. Yeah, so.
220 minus 220 is equal to 0. Good. So then what you would need to do is so we found that one of these is a factor, so x minus 2 is a factor. And then from this point, we would need to go and do a polynomial division. So then I would do polynomial division. And then my final answer will end up being, I've got x plus 3, x minus 2, 3x minus 2, 2x plus 3. That's, yeah, once I've done the polynomial division. So now I would need to list, because I still have to sketch the graph. So this will mean this will be an x-intercept at -3, 0. This will be one at 2, 0. This one will be 2/3, 0. And this one will be -3 over 2, 0. So, and the reason I got that is I just made each of those brackets equal to 0. So what I'm going to do is I'm going to sketch my graph. I'm going to use the template that I've been provided above to sketch my graph. So I'll just wait till people get that business up there. And I'm going to use the back of this sheet. Yeah. Okay, so it looks something like this. The y-intercept's at 36. The reason I know that is that's the number at the end. Two-thirds, 0. No, that should be 2, 0. And there's the graph. Where did that says 36? Where did the 36 come from? Because it's the y-intercept, and the y-intercept is the lovely friend at the end there when I replace x with 0.